Hi, welcome. Another episode of JEE NEET Chemistry with VenkatVarma. In this episode, we are discussing about alkyl halides and aryl halides JEE Main 2023 Jan session. Now look at for the question. A session. Hydrolysis of an alkyl halide is slow reaction, but in presence of sodium iodide, the rate of hydrolysis is increases. The question is, hydrolysis of alkyl halide is slow reaction, but in presence of sodium iodide, the rate of the hydrolysis increases. Generally, alkyl chloride, alkyl chloride hydrolysis it is a slow reaction. It becomes ROH2 plus to produce H plus. It is a slow reaction. So alkyl chloride in presence of sodium iodide, it gives alkyl iodide and sodium chloride. In this reaction, sodium iodide act as catalyst. In this situation, the rate of hydrolysis in presence of sodium iodide, the rate of hydrolysis increases. It is a assertion. It's true. It is true. In this example, I minus act as nucleophile. It act as nucleophile. I minus act as nucleophile. When it hydrolyzes, alkyl iodide hydrolyzes, it gives alcohols. The alkyl chloride with sodium iodide to give alkyl iodide, it is a halogen exchange reaction. The name of reaction is Finkelstein reaction. The reaction name is Finkelstein reaction. Halogen exchange reaction. Finkelstein reaction to prepare alkyl iodide from alkyl chloride and alkyl bromide. Now, the reason is, in this question, the reason is I minus is a good nucleophile. Yes, I minus is a good nucleophile. It is a good nucleophile. As well as good living group. Yes, it is a good living group. Why the I minus act as good living group means, see, for example, I minus is there, OH minus is there, and H2O is there, which has larger size, that has easily living the group. So in this example, I minus is a large size. Now it easily living group. It act as good living group. Now here also Cl minus, Br minus, I minus, chloride, bromide, iodide. In this example, I minus is a good living group. It is a good living group. And this question, which is the right or which is correct about the options? Both A and R are true. Assertion and reason is the correct explanation of the A, because The alkyl chloride hydrolysis is a slow reaction, yes, but in presence of sodium iodide, it is a fast reaction. It is a fast reaction. Why it act as fast reaction? I minus is a good leaving group and a good nucleophile. The option is third. The option is third. Now look at for next question. Number of moles of AgCl formed in the following reaction. Number of moles of AgCl formed in the following reaction. It is a specific reaction. Now silver nitrate. So I am writing the equation. How to decide the number of moles of AgCl is formed to decide the stability of carbocation. To decide the stability of carbocation. Stability of carbocation. Stability of carbocation. See, for example, I am writing the equation. See, chlorine, 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 it is a chlorine and a hydrogen. See, chlorine, 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 having 1, 2, 3, 4 chlorines are present. When it is treated with silver nitrate, means AgNO3, AgNO3 to form a carbocation. So, what are the possibility of carbocation? What are the possible carbocations? What are the possible carbocation? See, look at for possible carbocation. See, this is the tertiary carbocation. Tertiary carbocation. It is a secondary carbocation. It is a secondary carbocation. It is a phenyl carbocation. It is a phenyl carbocation. It is a vinylic carbocation. It is a vinylic carbocation. Vinylic carbocation. So, which is a stable carbocation? In the given option, which is the stable carbocation? Which is the stable carbocation? See, what are the possibilities? So, the secondary carbocation and tertiary carbocation are stable. The phenyl carbocation is very unstable. It is very unstable. It is very unstable. Vinylic carbocation also, it is also unstable carbocation. Unstable carbocation. So, to needed how many moles of silver nitrate? So, here possibility is secondary carbocation, tertiary carbocation. Means how many chlorines are leaving? 2 chlorines. It need 2 AgNO3, 2 AgNO3, 2 AgNO3. So, it forms A plus how many moles of AgCl formed? 2 moles of AgCl is precipitated. 2 moles of AgCl is precipitated. Now it is X equal to 2. X equal to 2. This is the answer for above the question. Answer for the above question. Now look at for next question. The maximum number of isomeric monochloro derivatives which can be obtained from 2,2,5,5 tetramethylhexane by chlorination is. Here asking monochloro derivatives. The possible monochloro derivatives. First of all, when chlorination, for example, I am taking small example for chlorination. For example, methane chlorination. Methane chlorination in presence of chlorine and in presence of HNO, it gives methyl chloride CH3Cl plus CH2Cl2 plus CHCl3 plus CCl4. It is a complete chlorination. It is a complete chlorination. Complete chlorination. This is the product. CCl4 is the product. So here asking monochlorination. Monochlorination means this is the monochlorinative product. It is a monochlorinated. It is a monochlorinated. Now I am writing the structure of 2,2, 5,5 tetramethyl hexane chlorination. Now look at for example. For example, C, CH3, 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 CH2, CH2, C, CH3. This is the name of 2,2. See, it is a 1, 2, 3, 4, 5, 6. This is a 2,2, 5,5 tetramethyl hexane. Now chlorinate this product. Chlorination in presence of H nu. In presence of H nu. It gives how many products? Monochlorination means, so for example, say CH2, CH3, CH3, so attacks here Cl, CH2, CH2, CH3, CH3, CH3. It is a monochlorinative product. See for example, CH3, 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 CH3. Now chlorine attacks where it attacks, it gives same product. For example, CH2Cl, here also CH2Cl, here also CH2Cl, here also CH2Cl. Now the compound is same name. So it has one of the structure, the name is same. Name is same. It is a possibility. The first one is, it is a possibility. Now look at for next one where it attacks. For example, CH3, 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 CHCl, CH2, CH3, CH3, CH3. Now, so it attacks the chlorine, means one chlorine attacks, it gives chiral center. It gives chiral center. So attacks this position or this position. They have same name. They have same name. Both are having the same name. So it has two isomers. One is positive and the other one is negative. Because of it has one chiral center. Possible isomers are, it is a chiral center means it is a optically active. It is a optically active compound. Here two possibles. Here two isomers are possible. Two isomers. It is one. The total number of isomers. The total number of isomers. The total number of monochloro derivatives are derivatives are 3. It is 2. It is 1. The possible is 3. Possible is 3. The answer is 3. Have a look for next question. Decreasing order towards SN1 reaction for the following compound. Now the decreasing order towards SN1 reaction for the following compound. See, the carbocation can stabilized by the delocalization of the charge via resonance. See, the delocalization of carbocation can stabilized by delocalization of the charge via resonance. See, look at for compounds. Say, first compound has nitro group, second compound has OMe, and third is chlorine, and D also having the chlorine groups. Now see for example alkyl halide, it gives alkyl carbocation and Cl minus to produce carbocation and Cl minus. The rate of SN1 reaction, see the rate of SN1 reaction depends upon the stability of carbocation, depends upon stability of carbocation. The stability of carbocation increases, SN1 reactivity increases. The stability of carbocation increases, the SN1 reactivity increases. Now I am writing equation about this. For example, this is a related A, it is NO2, the CH2 plus carbocation is formed. Now B compound, it is OMe with CH2 plus, and again the C compound chlorine with CH2 plus carbocation plus lone pair. Now CH2 plus, it is a phenyl carbocation. Now look at for NO2. NO2 is a electron with a drying group. Generally, what is a carbocation? See, carbocation stability is directly proportional to number of positive inductive effect groups. This is the concept of carbocation stability. Carbocation stability is directly proportional to number of plus inductive effect groups. Now again also energy is directly proportional to charge and inversely proportional to stability. It is also related carbocation stability. Now take NO2 is electron with a drying group. Electron with a drying group means minus M effect. It presents the minus M effect, strong minus M effect. Now OMe, so oxygen is a more electronegative element. So oxygen has lone pair of electron. It is electron donating group. Means it is a plus M. It works as plus M effect. So oxygen has negative charge. It acts as negative I also, but plus Me is dominate minus I. Now look at for chlorine. Chlorine has lone pair of electron. It shows plus M effect, and chlorine has more electronegative element. More electronegative is a I negative or negative inductive effect. Here negative inductive effect dominates plus M effect. Now look at for example. So which is increases stability of carbocation or SN1 reactivity. See, which has electron donating group that has more stability. The first one is, see, this is the first one is CH2 plus and OMe. It is a electron donating group. Again, see, phenyl carbocation. There is no groups. The remaining two groups are having minus mesomeric effect or minus M effect and minus inductive effect group. Now weakly electron with a drying group is a chlorine. That's why I am writing this one. Again strongly electron withdrawing group is the NO2. NO2. So the most decreasing order towards SN1 reaction is, it is a B structure, it is a D, it is a C, it is a A. This is the order of decreasing towards SN1 reaction. SN1 reaction, the option is B, D, C, A. The option is 3. The option is 3. Have a look for next question. The correct order of melting point of dichlorobenzene. Dichlorobenzene. Now look at for this structure. The first one is 1,2 dichlorobenzene and 1,3 dichlorobenzene and 1,4 dichlorobenzene. See, 1,2 dichlorobenzene is orthochloro, and 1,3 is a metachloro, and 1,4 is a parachloro. So here asking related to melting point. Generally, melting point based on strength of the lattice structure of the compound. Melting point based on strength of the lattice structure of a compound. Okay, the boiling point of isomeric dihalobenzenes are nearly same, but melting points are different. Here look at the boiling point, it is nearly same. It is a nearly same, but melting point is different. Melting point is different. Okay, see the melting point of para is between 70 to 100 degrees Celsius, which is greater than melting point of ortho and meta isomer. The higher melting point of para isomer, it is due to symmetry. Now have a look for this structure. See, it is a 1,4 dichlorobenzene. It is more symmetrical. Better crystal fitting. It has better crystal fitting. Para dichlorobenzene has high melting point. See, para dichlorobenzene has high melting point due to symmetry or symmetrical. Now look at for ortho, means 1,2 dichlorobenzene. So for example, it has mu maximum, dipole moment maximum, its theta value is 60 degrees Celsius. It is a 60 degrees. Now look at for metachloro. So its theta value is 120 degrees. Here mu of ortho is greater than mu of meta. The most important point for packing efficiency, how much is highest packing efficiency, that has more melting point. More packing efficiency has more melting point. See, more packing efficiency is directly proportional to more melting point and directly proportional to symmetrical structure. So above question is para is greater than ortho is greater than meta. The correct order of melting point is para dichloro, second one ortho dichloro, and meta dichloro. So the given option is fourth one is correct. Option is fourth. Have a look for next question. Identify incorrect option from the following. Incorrect option from the following. So let us take first one. See, one bromo, 1 2 3 propane. It is treated with aqueous KOH. Aqueous KOH means it gives substitution. The bromine is substituted by OH. OH. It is a correct statement. It is a correct statement. Have a look for second reaction. See, it is a bromine with alkali KOH. We are using the alkali KOH. It gives the elimination product. It gives elimination product. But here gives the substitution product. Substitution product. So, which is a wrong statement? I think this is a wrong statement. Go for next. It is a elimination reaction, but here giving the substitution product. Have a look for third option. Have a look for third option. Chlorobenzene. Chlorobenzene treated with acyl chloride CH3 C double bond CO Cl in presence of anhydrous AlCl3. Anhydrous AlCl3. Anhydrous AlCl3, it gives electrophilic substitution product. It is a electrophilic substitution reaction. It is a electrophilic substitution reaction. This is the Friedel-Crafts acylation. It is a Friedel-Crafts acylation. Friedel-Crafts acylation. It is also correct for the reaction. Have a look for the fourth option. To check the fourth option, see chlorobenzene treated with sodium hydroxide at 623 Kelvin temperature at 300 atm pressure and presence of HCl. So it gives first of all sodium phenoxide, again treated with HCl. It gives the phenol. So in this reaction undergoes benzene intermediate. Benzene intermediate. So it is also correct. Which is wrong? The second one is the wrong, because here giving the alcohol, so bromine to alcohol, but the reagent is alkali KOH. Alkali KOH means it undergoes elimination, but it gives substitution product. The option is 2. Option is a 2. Thank you.